Here we can learn the ways in which to create and modify interior stairs. In the sample plan we can see that the interior stairs has a few straight steps and few angular steps. In this case it is easier to create stairs by sketching the outline of the stairs rather than using the automatically place stair option. We can go to the plinth floor view and start creating. First we can click the stair button in the Architecture tab. This opens the Stair Contextual tab with the different tools to create and modify stairs. In the Properties bar we can change the type of stair required. I am selecting the Assemble stair. Select the base level and top level. Since we are creating stairs from plinth to ground floor roof level, we can choose those levels as base and top. We can also change the number of risers to 20, as that is the number of steps needed to connect plinth to ground floor roof. Then let us look at the Contextual tab. There is a Components panel showing the different types of stairs which can be drawn automatically. However, when we need a specific shape of stair, it is easier to create the stairs by sketching the outline. So we can choose the pencil icon which opens the Sketch Stair tools in the Contextual tab. Now let us look at the Drawer panel. It has three major options: boundary, riser and stair path. Boundary is the outer and inner lines which connect all the treads and risers, and it is represented by green lines. Riser line is the line representing each riser, and it should always touch two boundary lines. Stair path is the line denoting the path of the stairs. First we can draw the outer boundary lines using the line tool. We can create the landing boundary by offsetting the outer line to 1 meters. Now looking at the inner boundary, although it looks like a single line in plan, we need to create the two different lines. Hence we can use the offset option so that we can draw two lines at 10 centimeters from each other. Now we can fillet the landing and inner boundary lines. Once the boundaries are drawn, we can draw the risers in their respective positions, making sure that they touch both the interior and exterior boundary lines. When there are similar elements to be drawn on both sides, we can use the mirror tool to create the lines on the other side. We can use a tread width of 30 centimeters to offset the lines. Each riser line creates one step. If during the offset process two lines are created in the same place, an error window shows up and the error is highlighted in orange color. We can delete the extra line. We can use the fillet and other modify tools to help us draw all the lines correctly. Once the boundary lines and riser lines are drawn, we can use the stair path option and draw a continuous line connecting all the risers from start to finish. Now if we click on the Finish button, the stair gets created. If there are any errors in our drawing, an error window opens showing the error. Here a boundary line is missing, so we can draw it. Now we can finish the model and stair is created. When we create a stair, its railing is also automatically created. Now we can again click on the Finish button to close the Contextual tab. Now to check the placement of the stairs, we can create a section such that it cuts the stairs. If we go to the section view, we can see that the ground floor roof slab cuts through the stairs. We can go to the ground floor roof view to edit it. When we know where the floor slab ends but the floor slab is not visible, we can place the cursor over that point and click the Tab key on the keyboard until the floor is highlighted. Then we can click the floor and select the floor. Going into the Edit Boundary option, we can add a rectangle in the area of the stairs. The area for the landing is also outlined. Now we can finish the floor. As per the sample plan, the stair wall extends up to the end of the stairs, so we can select the wall and using its start point we can pull it to new position. Now we can see in the section view that the floor slab has been cut. As the outer side of the stairs are surrounded by walls, we can select the outer railing and delete it. We can go back to the section view. As the railing was created by default, we can select the railing and try changing it to the different types available. First we can select the railing. Then from the properties bar drop down we can select the other available railings. The stair railing changes to the railing we selected. We can apply different railings and choose what fits best. We can also load railings. But to save time during exams, it is better to choose railings from what is available. We can see that the slope of the railing varies with the type of railing selected. We can edit the properties of the railing or change the railing itself to accommodate our needs. Now we can change the visual style to realistic to check again the elements. We can also try and change the stair type. The available stair types each have very different riser levels set by default. This is why when we change the type of stairs, the height of the stair also changes based on the preset riser level. Some railing types cannot be used with some stair types. In that case, there is a warning window and the railing gets deleted. We can see now that the stairs are created such that what should be at the top is now at the bottom. We can change this to the correct orientation. Just select the stair and click on the Edit Stairs option. In the Contextual tab there is a flip button. By clicking on it, the orientation can be changed. Now we can see that the direction of the stairs is correct. However, the height of the stairs has changed as we changed the type of stairs. So we can select the stair and then click on the Edit Type button. In the Type Properties window we can see some rows under Calculation Rules. The riser and tread of the stair type is calculated based on these rules. We can change the riser height to 15 centimeters. Now after clicking OK, a warning window shows up stating that the height has changed. Now we can see that even after changing the riser height, the changes have not been applied to the stairs. This is because sometimes Revit is slow in recalculating the stairs. In this case, we can change the top level to a different level and then again change back to the desired level. Now we can see that the changes have been applied. Because we flipped the stairs to change the stair orientation, the handrail also has flipped from inner side to outer side. So we can go to the ground floor roof plan view to correct this. First we can delete the outer railing. Clicking on the railing button in the Architectural tab activates the railing command. Then using the line option in the draw panel we can draw the outline of the railing. Then we can click the finish button. When railings are drawn independently, they do not automatically connect to the stair. So we can select the railing and then using the Pick Host button in the Contextual tab we can then click on the stair to which the railing should be joined. If there are any errors, a warning window pops up. Here we can click the Delete Instance button to remove the error. We can see in the section view that the railing has been placed correctly. However, the railing should also extend to the landing on the first floor. So we can go to the ground floor roof plan view. By selecting the railing and right-clicking to the Create Similar option, the railing tool is activated. Railing lines are always drawn as center lines of the railing. So we can use the midpoint center line as reference and extend the railing. Now we can again connect the railing to the floor slab by clicking on the Pick Host button and then selecting the floor slab. Now in the section view we can see that the height of the railing is not correct. So we can try changing the railing type to the 900 mm railing. However, this too is not exact. So we can select the railing and go to Type Properties by clicking on the Edit Type button. There in the top rail height we can increase the height by 5 centimeters. Now we can see that the railings have aligned properly. In the same way we can add the exterior railings too. First let us go to the plinth view and create the railings in the sit-out area. First we can click on the railing button to activate railing tools. Whenever the Save dialog opens, save the project so that all our effort doesn't go waste. Now using the line tool we can draw the railing. As the railing is always drawn as center line, make sure to draw the lines with a small offset from the external boundary so that the railing places properly within the boundary. Here I am moving the already drawn line to make sure the railing gets placed correctly. Now we can click the Finish button and see that the railing thickness is now inside the sit-out boundary. We can also go to the 3D view and check the placement. In this same method we can go to the ground floor roof plan view and draw the railing. Since the first floor railing is a long continuous one, I am choosing the line tool and then using an offset of 5 cm. Now when we trace the outline of the floor slab, the lines are automatically created at the desired offset. We can use the spacebar key to change the side in which the line is placed. In this way the whole floor boundary is traced and the railing lines are created. Now we can go to the 3D view and check the railing to see if there are any changes. We can also change the type of railing. Select the railing and then from the Properties bar drop down we can select the desired railing type. I am changing the railings to a glass type. We can apply the same changes to the railing in the sit-out area as well. Following these series of steps, different types of stairs and a variety of railings can be created, edited and modified in Revit.